So, have you ever wondered how a massive financial company, a real giant, can actually use AI without, accidentally breaking a whole bunch of federal laws? Well, today we're going to go inside a real world proposal for Fiserv, a major player in financial tech. We're going to look at the exact blueprint for building an AI platform that's not just powerful, but also safe, secure, and totally compliant. Okay, let's dive right in.
First things first, we really have to get our heads around the core problem. I mean, everybody knows AI has this incredible potential, right? But for a company in a super regulated industry like finance, the risk is just as huge. So the big question is, how do you bridge that gap from this cool, abstract theory to safe, real-world, compliant execution? That is the challenge we're unpacking today.
And wow, this image just says it all, doesn't it? On the left, you've got the messy reality for a company like Fiserv. It's this chaotic storm of billions of transactions, tons of raw data, and this spiderweb of compliance rules like PCI DSS for card security and Sarbanes-Oxley for financial reporting. In that world, you have absolutely zero tolerance for an AI just making things up. So the solution, over on the right, is to channel all that chaos into a governed, validated, and auditable pipeline. It's a platform with safety literally baked in from the ground up.
All right, so how do you actually build that pipeline? Well, it all starts with a rock-solid architecture that's designed to scale. Let's pull back the curtain and look at the blueprint for how this whole AI ecosystem comes together.
You know, what's really brilliant here is that this isn't just one giant AI brain. It's a unified ecosystem that's built for control and for oversight. Right in the middle, you have the Enterprise AI platform, and it connects 4 key services. There's a RAG assistant for smart, verifiable search, a web dashboard for the users, an automated risk assessment tool to flag any issues, and a dedicated AI governance service to track and audit absolutely everything. And notice, each piece uses the right tech for the job. Python for the heavy AI lifting, .NET for governance, and React for that slick front end.
So let's pop the hood for a second. We're looking at a classic microservices architecture, and it's decoupled for a really important reason. A user request comes in through the front end, it hits an API gateway for all the security checks, and then it gets routed to either the AI service or the governance service. See how they have their own separate databases? That separation is absolutely crucial. It means the AI service can scale up or down independently without ever messing with the critical governance and audit logic. And that architecture, it wasn't an accident. It's the result of some really key strategic decisions. First, they chose microservices over one big monolith. Why? For better stability and scaling. Second, they're using both asynchronous Python for those heavy, long-running AI tasks and synchronous .NET for the fast, super reliable business logic. And third, they use something called polyglot persistence. It's a fancy term that just means they use the right tool for the right data, SQL for structured compliance info, and a special vector database like Pinecone for the AI's semantic search. Smart.
Okay, so we've got the architecture down, but how do we make sure the AI at its very core is actually telling the truth and not just, making stuff up? This next section is all about grounding these powerful models in verifiable, factual data. It all starts with the technology that powers models like GPT-4, the transformer architecture. Now, we could spend a whole day on this, but the most important detail for compliance is right there in that bottom right box. The system uses a super low temperature setting of 0.1. You can basically think of this as the AI's creativity knob. They've turned it way down, forcing it to be more deterministic and factual, which is exactly what you need in a regulated world. But here's the thing. We don't just let that powerful model run free. No way. We control it with a process called Retrieval Augmented Generation, or RAG for short. Here's how it works in 3 simple steps. First, ingestion. All the approved company documents get broken down into little chunks and turned into numbers. Second, retrieval. When a user asks a question, the system searches for the most relevant chunks from those documents. And only then in step 3, generation, is the AI allowed to create an answer, and it can only use the approved text it was just handed. It even has to provide citations, like a good research paper. And this isn't just a diagram on a slide, folks. Here's a look at the actual code that makes it happen. You can see it right there. Temperature equals 0.1, locking in that low creativity setting. You can also see the connection to that Pinecone vector database. And see that async definition? That's key. It makes sure the whole system stays snappy and responsive for the user, even while it's waiting on the AI to do its work. But it gets even cooler. The system can go beyond just answering questions about documents. It can actually take action. It does this with something called an agentic loop, or REACT, which stands for reason, act, and observe. So, for example, If a user asks, hey, is Project Alpha risky? The AI can reason that it needs live data. It then acts by calling a tool, like the one in the code here, that gets a project's risk score from a database, and then it observes the result to give a final up-to-the-minute answer. This turns it from just a search tool into a dynamic, interactive assistant. Now, the very first line of defense in all of this is the system prompt itself. Just look at these rules. Rule number 1, right there, highlighted. Answer only based on the provided context. And then rule number 4, do not hallucinate or invent policies. These strict, non-negotiable constraints are what turn a powerful creative language model into a verifiable and trustworthy search engine for the entire company. But how do we actually prove this thing works? I mean, you can't just go on vibes, right? So the system is evaluated on 3 key metrics. First, faithfulness. Did the AI's answer stick to the original documents? Second, relevance. Did it actually answer the user's question? And third, this is really clever, they use a technique called LLM as a judge, where another powerful AI is brought in to automatically grade the answers. That ensures a really rigorous and unbiased evaluation. You know, a good plan also anticipates what could go wrong. It thinks about the common pitfalls of working with these big language models. So for things like context window limits, it uses smart chunking. For hallucinations, it's got those strict system prompts we just saw. For slowness or latency, it uses asynchronous execution and caching. And for that weird lost-in-the-middle problem where models can forget info, it uses overlapping chunks. Every single challenge has a planned-out engineering solution. Okay, so a factual AI is one massive piece of the puzzle, but operating it safely within a huge enterprise, that's a whole different ballgame. And that's where this crucial safety net comes in, this multi-layered defense that's built around the entire AI. This all starts with the governance engine, built on .NET for its rock-solid enterprise reliability. Its main feature is the project registry, which is basically a dashboard that tracks every single AI project in the company. And the goal here is to prevent shadow AI. You know, those rogue projects that pop up without any oversight, creating massive security and compliance risks. This registry provides a single source of truth for all AI development. And for every one of those projects, risk is managed with this automated assessment matrix. It scores each project on 4 key areas: data privacy, bias and fairness, transparency, and regulatory impact. Now, the most critical rule is right there on the side. Any project that scores over 75 out of 100 automatically triggers a mandatory human review. It's like a built-in circuit breaker to make sure a human is always in the loop for the high-risk stuff. Think of security like a bank vault. It's not just one big lock, right? It's layers and layers of defense. This safety stack applies that exact same principle to every single user request. Layer 1 filters out harmful content. Layer 2 validates the data structure. Layer 3, that system prompt, prevents attacks like prompt injection. Layer 4 validates the output, stripping out any sensitive data. And finally, Layer 5 creates an unchangeable audit log of the entire transaction. It is truly defense in depth. And of course, we have to talk about data privacy. It's paramount. And there are 3 principles here that are totally non-negotiable. First, data isolation. Fiserv's data is processed through a private endpoint and is never, ever, ever used to train public models. Second, encryption. We're talking top-tier encryption for data as it's traveling across the network, that's in transit, and while it's just sitting in a database or at rest. And third, secrets management. No passwords or API keys are just sitting in the code. No way. Everything is managed securely through Azure Key Vault. So we've got the architecture, we've got the factual AI engine, and we've got the safety net. The final piece of the puzzle is execution. How do you actually take this incredibly detailed blueprint and turn it into a working reality? Well, execution is all handled by a modern DevOps pipeline. Think of it like a high-tech assembly line. A developer pushes their code, which automatically kicks off a bunch of tests. If the tests pass, a container image is built. That image is then deployed to the cloud where it runs as an auto-scaling application. This whole process, called CI/CD, ensures that every single change is built and deployed in a consistent, reliable, and totally automated way. And what's really, really smart about this whole design is that it's also future-proof. It's built to be cloud agnostic. As you can see on the slide, by changing just one line in a configuration file, the entire system can switch from using Azure's AI models to using AWS's models, or vice versa. This completely avoids getting locked into one vendor and gives the company maximum flexibility down the road. And here's the timeline to make it all real. It's an aggressive, but super clear 30-day action plan. Week 1 is all about getting the foundation right, security setup, and the first RAG prototype. Week 2, you build out the application, adding tests and plugging in the governance tools. Week 3 deepens the capabilities with that agentic AI. And by week 4, the system is deployed to a staging environment, totally ready for a stakeholder demo. From zero to a working platform in just 1 month. Pretty incredible.
But, technology and timelines are only part of the story. The plan wraps up by emphasizing that the right culture is just as critical. This AI engineer's mindset requires being curious, always asking how AI can help, being experimental, willing to fail fast and learn from it, being honest and transparent about the system's limitations, and above all else, being ethical, always prioritizing customer trust and safety over just moving fast. So there you have it, a complete blueprint for building an AI platform that is secure, compliant, and absolutely ready to implement. It just goes to show you that with the right architecture, rigorous safety protocols, and a clear, actionable plan, you can totally bridge that AI divide, even in the most demanding industries out there. Which leaves us with a final question to think about. This is the blueprint for finance, a really high-stakes, regulated field. What rules from this playbook do you think should govern AI everywhere else?